Hi guys, today we're going to do a Hangman game. It is going to be more complicated, or at least compared to previous tutorials. So go to your projects, to tutorials project, source, and the first thing we're going to do is create a file called words or something, from which we'll be reading our data for for the game. So it is important that you create the folder resources here under the source code as opposed to the one that we have here outside the source code, because this is used for sort of like internal reading. And what we're going to do is make sure that our program will then be able to package our program and it'll still work. So right click on your source folder, new folder, call it again resources or res, and then create new file under the res. New file, call it words.txt. And this file will contain all the words for our Hangman game. So if we just type some random words, compilation, project, computer, just any words, doesn't really matter. We'll be using these just for test, and then you can download some kind of dictionary and then put all the words in this file so that you can use them in the game. Now create a package called tutorial 13, and I already have the two files that we'll be needing for this program or for the game. First of all, we're going to do a word reader, and it's pretty straightforward because we've already done that several times. The only difference is that we're going to use resource as stream as opposed to using static methods from the files class. And the advantage of using this construct is that even if we package our program into an executable jar file, this will still run and find the resource where it is, as long as we put the resource folder right under source folder. So we define our constant, which is the path to our words file. So the first slash means that it is a relative path. So if resource is under some other folder, it should find it, but this is the perfect sort of ideal place for it to be. So yeah, just like that, res and words. Then we have an array list of strings, which are going to be words. So when we construct our word reader, we create, or we do a try catch block, try with resources. So input stream, we get the class which is basically returns class of word reader. Then we're going to load resource as stream. So this will get our file and it will parse it into an input stream. Finally, we put the input stream back to input stream reader, which is again a new parser for the input stream, and buffered reader will simply make it readable for us, so line by line. We create temporary storage for each word basically. So while we read the line into the variable line, and while it isn't null, if it is null, it states basically, it shows that it's the end of the file. And while it isn't, add our word to the words list. If there is an exception, just say we couldn't read file or couldn't find it, and display the error message. And there is just one method which will say you get random words. So every time you run the game, or every time you start a new game, the word will be randomly taken from this words list. So if because when we create a word reader, when we construct it, it will load all the words into the array list. So if it hasn't done so, for example, an exception occurred, then the words list will be empty. And if it is empty, just return no data, so that we couldn't find anything. And if it isn't, then return a random word, but first get random index inside the array list. So multiplying math.random by the size of the list will return a valid index to that list. So we can return a random word from that list. Now back to our main application, which is slightly bigger than usual. I'm just going to collapse everything. Okay, so what we have? Well, we have our main method to run the application as always. So this should be more or less familiar. The imports, if you need them, so you can just manually type it right now, so you don't have to worry about them later. Again, we define our width and height for the application. We create our default font, which is of type Courier and size 36. This should be available on all platforms, I believe. If it is not, then you'll use some other default font. So points per layer is again another constant, basically how many points you get for each letter that you've guessed right. Bonus modifier, this is the amount by which your bonus increases. Now, simple string property is basically a string which is an observable bean, so you can bind its value, or you can bind to its value. Yeah. It is useful for like communication between UI and your logic fields. Then we have number of, so this is basically the word that we're going to guess, and letters to guess is the number of letters left to guess. Yep, just basically read the comments. This is the current score, which we're going to keep. Score doesn't really matter because we still have sort of the Hangman image. This is the current score modifier. So bonus modifier is by which amount this value increases when you get the letters correctly. Playable boolean is basically if the game is playable, then this boolean property will be true. If not, it will be false. So we can bind other properties to that, so the game is not running if it's not playable. So we don't have to do things manually. Properties basically allow us to forget manual assignment, things like that. This is the alphabet. Well, you'll see this later. These are the things that are needed for user interface. And our word reader, the one we created right here. So this is the reference to that. We create no word reader, and then we can use it to get random words from the text file. Okay, so shall we start from the Hangman image? Yeah, so this is basically the image that is drawn the Hangman image that will be drawn if you get letters wrong. So actually, let me show you. It should run now. Yeah. So at the end, we'll have something similar to this. Hangman with more of a Wheels of Fortune kind of theme. This is the alphabet that is shown, so these are the letters that you get, plus the symbol of hyphen that you can type on your keyboard. And when you do, so let's press A, if it isn't in the word, then you'll have sort of part of the Hangman image drawn. And when the Hangman image is complete, then you lose, or at least you lose the level round. So yeah, that's the word computer that we just typed to the words list. So you'll get one of these. Obviously, you'd want them to be, the file to be as long as possible. So when we press the key on the keyboard, it will find this letter and then it will strike through it, so that we know that it has been used already in the game. It will also change the color to blue. What else? Then we have a button to start a new game once this game has been completed, or you either lost or you won. And let's just get the Hangman image complete. So yeah, when you lose, or you don't have enough sort of parts of the image to draw, then you lose and the complete Hangman is drawn, which is basically a stick man with a filled circle. Actually, I should have it up so you can see the thing. So yeah, this is the Hangman image that we're drawing. We define our constants first. So because it is it will use its own coordinate system, so these coordinates are really local to the image, so we don't care about the world coordinate system. In the world coordinate system, it is something like in x direction 300, in y direction maybe 200, but while it is a isolated separate node, it will use its own local coordinate system. So it is a very good thing for us, because we don't have to worry about anything else. So these are basically 2 points. This is 1 point, start x and y, so spline start x and y, so it's basically here. And spline end x and y is here. And these 2 points define sort of the foundation for our Hangman or stickman. Lives is basically an integer keeping track of how many lives left. If we do this, so this is our Hangman, or the code for creation of our Hangman. So the head is circle, we said translate to spline start x, so its center is here. 20 is the radius of the circle, and by default it will be black, so we don't have to set the color or set fill. And we define all these lines. So spline is just takes these values, so this is line spline, left arm, this is right arm, this is left leg and right leg, so it's straightforward. And you simply get children, so we're extending a parent. We'd get children, we'd add head, spine, left arm, right arm. Doesn't really matter what order you add them in, because they are not really overlapping. And we set lives as the number of elements in the parent, so number of children basically. this will allow us to have lives equal to the number of parts our Hangman image has. Then we have a method to reset the image. So basically, for each child, set invisible. So set visible false will make it invisible. And lives, again, set number of children. So however many lives there were left, just set it to default. And take away life is go through all the children, iterate over them. If it's not visible, set visible to true, and set lives to minus lives, or -1 life. And break out the loop, otherwise it will just go through all of them and then display all of them. And we just want 1. Now, yeah, let's do letter. Letter is basically this, and this as well. So they're basically the same class, or same they're different objects, but they're the same class. It's just the existence of a letter within it. So what we do is create a rectangle, which is going to be our background, define width and height, and the text, which is this part. So this object, or this particular object, doesn't have a text associated with it, and this does. So when we create a letter, we pass a character, because one letter is represented by one character, or a single character. We set fill based on the letter. So if the letter is empty, so if we're passing nothing, we create, or we set fill to this color, dark sea green, which is this. Obviously you can pass any color you want and design your own application. And then if it's not, then we set white, so the background will be white. We set stroke blue. Stroke is basically the thing that surrounds the rectangle, in our case, the rectangle. Again, you can use your own colors. Then we create our text, and we take the value of the letter that we pass to it, and then we capitalize it. So basically change the case of the letter to uppercase. We set font default font, which is the one we defined previously. So this was the default font. Set visible false, so we don't, when we just create our structure, the text is by default is not visible. Set alignment center, as you can see, the text or the character is centered within its parent. And finally, get children and add background and add text. And letter extends stack pane. So whenever there's one thing on top of the other, you're likely to use stack pane, as opposed to just parent that we use with Hangman image. So there's a method to show the letter, and we're going to do this kind of fancy animation. So when you get the letter right, it will spin around its y-axis, and then when it's done, it will show the letter. And for that, we'll need rotate transition, duration 1 second, and we set the node to rotate, and this node is the background, so the background rotates. We rotate it around its y-axis. Y is basically this line that goes vertical line, and we'll rotate around that line to angle 180, so it will do just one spin. And unfinished is basically the code to be called when the animation has finished. And when it has finished, just set text visible, and play the animation. So that's for show. We can call the letter We can call the method on the letter to show it when we guessed it right. And this is the method to check whether we got the letter right. Is equal to a character another. So you pass other character and then you check where they are equal. So you first of all change the case again to uppercase, and then just check whether the text of that layer equals to the layer that we passed. Okay, now, yeah, that should be right. Let's go to create content. First of all, we create a row of letters and set alignment to center. So a row of letters is this part. We do it, we have the observable list of letters which link to the actual letters of the word. So we get children and we assign it to the field letters, so we can modify them later on if we need them. So we don't have to have access to the actual horizontal box. What we need to have access to is basically the children. Playable is the Boolean property, if you remember, that basically tracks if the game is playable. And the game is playable if, so we bind the expression, or bind the property value of playable property to the expression. And this Boolean expression is if Hangman's lives are greater than 0 and layers to guess is greater than 0. So we have left layers to guess, and the we haven't completed the Hangman image. So basically it says this. And then playable add listener, this is one way of defining lambda. So this is the observable value. This is the old value and this is the new value. So it basically track what happened whenever the playable variable or property changes. It will call this listener and this code will run. So if the new value, we take the Boolean value because this is the Boolean property. So if it's false, so if the playable is false, which means that the game is not playable, then stop the game. This is our button, which is this part, new game. So button again, new button. New game is the name of the button and the text that will appear on the button. We bind its disable property to a playable property. So if the game is playable, then the button will stay disabled. As long as the game is not playable, which means that this property will be set to false and this will automatically enable itself. And set an action is the code to be called when the button is pressed. And when you press the button, we start the game. These are first and third row, so this part and the green part. Set alignment position center again, so it is centered within the horizontal box. For 0 to 20, so there will be 20 of these empty letters. We create a new empty letter and add it to the children of appropriate row. And finally the row of alphabet, which is this part. Again, it is horizontal box, which means that elements within the box will be laid out horizontally by the JavaFX layout system. Then we set alignment to center, as always, so it is centered within the horizontal box. For a character, capital A to capital Z, so we can do this with characters as well, like with integers. we create new text. Text is a node that can be displayed on the screen. We set font default font. We put the character and the text associated with the character. So text is basically the UI part, user interface part. And this is the character of that text. So we put that to the alphabet so we can then have access to the text through a character. And finally we add this to the row of to this row. And because it will only capture A to Z, so all the letters in the alphabet, we also need to have a hyphen because some words might be hyphenated. So basically we do everything like this. Text score is this part. We bind its text property to score property and concatenate it with the string points. As you can see, whenever something changes, we don't really set anything manually. Everything is either bound or has been added a listener, so everything is done automatically pretty much. Row hangman is what's it again? Button. Oh yeah, so this is the row hangman, is the horizontal box that contains button, text score, and the hangman image. And the 10 is the gap between the elements within the horizontal box. And again, we set alignment to position center, so it is in the center in the horizontal axis. And the overall layout, so the sort of root layout, is vertical box, which, as you can see here, it contains this, that row alphabet, and this horizontal box. And it is exactly like this, so you can pretty much map row 1, row letters, row 3, row alphabet, and row hangman. Stop game is just basically show all the letters. So go through the letters, typecast it to a type letter, because initially we obtained an observable list of nodes to the letters horizontal box, and therefore we have to typecast the node back to our letter and just show the letter. So each letter will be shown once we lost, but if we won, the letters are shown anyway, so nothing will happen. Start game. For text alphabet values, so for each text, text, if you remember, is the user element, user interface node for our letter. So go through all of them, set strike through false, so we put them into default position where it's black, color black, and there is no strike through. We reset our hangman, so this start game could be reused to call start game again anytime. We reset our hangman image, and it will call this method, which we covered. Word set word reader get random word to uppercase. So we get a new random word from the word reader and change the case again to uppercase and set it to the word that we're looking for. Now letters to guess is the integer property, and as it says here, how many letters left to guess. So these Java comments are really useful if the application is too large. And this isn't really very large. It's about 300 lines, I think. Yeah, about. Letters to guess set. So we've done that. Basically, get the length of the word, and then because it's not a string, it's a string property. It will give us an integer binding, and then we get an integer primitive. letters clear. So we clear the list in this horizontal box, or the list that we have, which is the children of that horizontal box. For each character in the word, so we we convert the letters of the word to a character array, and then for each character within that array, we create a new letter and then add to the letters list. And finally is the start method, which is also basically like our game logic. You should be familiar with this because this is pretty much what we do every tutorial. Scene, create content. We set resizable false to our stage. We set width and height to our application width and height. Set title Hangman or whatever you want to call your own game. Then set scene, which is this scene. Show the stage and then start the game. And this part is set and key press, so when the user presses the key. You could also change it to key typed, so that key pressed is called when the key is pressed. Key typed is called when the key is pressed and then released. So that's the difference between these two callbacks. This is a key event that you get from generated. So yeah, this is the generate event when the user presses the key. If its text is empty, then return. So basically we're going defensive programming style. We said just return if it's not, if the parameter doesn't satisfy our requirements. Character pressed. So basically at this point it is no longer empty, and we definitely know that. So we can get text to uppercase and get 0th character or the first character in that text. And if this character is less than letter A or greater than letter Z, and it doesn't equal to hyphen, then return, because that would mean that user pressed something else, some kind of numeric key or control shift modifier, some kind of key. So we're not interested in that. We only want the actual letters plus hyphen. If the game is playable, so this is basically execute if the game is playable. We could again do this kind of thing. If the game is not playable, return, so that we return, and then this will be executed afterwards. We get the pressed key from the alphabet, which is the user interface representation, which is the text. If it is strike through, then that would mean that we have already guessed it, so we simply return again. Nothing will be executed beyond this point. And if we do go to this line, which would mean that it is not strike through, so we haven't used this letter, and we mark the letter used, so we set fill to blue, like here, and we set strike through to true. This is a boolean, just a local boolean to keep track whether we found the letter or not, we guessed correctly. So we first mark the letter used and then check whether it is the correct letter. For each letter within letters, basically within letters list, we check if it is equal to the one we pressed. If it is equal to it, then we set found to true. We set score to score get plus the score modifier multiplied by the points per letter. And we set letters to guess 2 minus 1 because we have already guessed one letter. And then we show the letter. And this will run for each letter, so if there is more than one occurrence of that letter, it will still work. if not found, so if we guessed at least one letter, found will be true. So if not found, then take away life from Hangman, which we covered right here. Score modifier is set to default, which is the 1. Else, so if we did find the letter, then score modifier plus the bonus modifier. And that's pretty much it for the logic. I will put up the link to the source code because there's quite a lot of code to cover, so you can download it straight away and use it. But still, I suggest that you sort of go through the video again if you didn't understand certain parts. And yeah, if you have questions, that just write in the comments section or send an email. I'll try to answer as soon as possible. And thanks for watching.